5.4, solving special systems of linear equations. Standard 8EE8. We can see over here with the skills, you can put a big check mark. We've already solved systems by graphing. We solved them by substitution. We've solved them by elimination, where we've found out that we've had one solution, whereas that point of intersection. However, now today we're going to look at infinitely many solutions as well as no solutions. That's all we're going to add in today. When we talk about solutions of systems of linear equations, we're used to this where we've had one solution right here where they intersect, that point of intersection, which you can see all three of these in your notes in front of you, but I'm going to go by them one by one here on my screen. So the lines intersect, that's where we had one solution, 3, 4, a -10, -8. Now, today we're going to see where we have no solution. Notice, key phrase here, these lines are parallel. They'll never intersect, they'll never touch because they're parallel. That's why they have no solution. Remember, no solution can also be written this way as no solution. And then today on your notes, you can see infinitely many solutions. The lines are the same, but when we write down this infinitely many solutions, you're going to see me, Mr. Wallace's class, say that you have to write down the phrase infinitely many solutions on the line, and then you're going to put down one of those equations from the system. I'll explain that here in a moment. Now, today, it just says solve. If it tells you a way to solve it, then let's solve it. Solve by graphing, it says. So here's our first equation. Up there, graphing, I'm going to put a point on +5, 1, 2, 3, 4, 5. And then use that slope of -2, which is -2/1, so down 2/1. I'm going to put a dot. And just as before when we talk about graphing, I'm going to continue going down 2/1 as much as possible. So that way it helps me find a point of intersection. Down 2/1, down 2/1. You can also go in reverse, remember? So from that y-intercept, instead of going down 2, right 1, we can go up 2, left 1. We have all these different points here that lie on our graph. Now you grab a straight edge because we're graphing and graph that line. Make sure there are arrows on it, and then from there, we'll do this guy. Again, +1 for a y-intercept, so I'm going to put a dot there at +1. And then a slope of -2. Oh, similar slope, so then we're going to have -2, down 2/1, down 2/1 the whole time. And then you could do the same slope going backwards the other way. Up 2/1, up 2/1, up 2/1, up 2/1. And then grab a straight edge and connect those. Arrows on either side, and notice they are parallel. They are never going to intersect. So we do not have a solution because there is no intersection. That's where the answer, no solution, comes in, which you can abbreviate with that little 0 with a line through it. Same system of equations, whether you graph it or if we use substitution. Again, is one of them set up as y equals? Great. Circle up everything else. They both are. Then pick one. I'm going to pick the first equation. Circle everything up after that equal sign. Because it says y equals, I'm going to plug this into the y down here. So -2x plus 5 equals -2x plus 1. Solve that. I'm going to get my variables on the same side. So I'm going to get rid of it here on the left side. So I'm left with 5 equals, oh, these guys cancel. All right, that's all right. 5 equals 1. Is that true? No. So since it is not true, there is no solution. You need to show that false statement, not just seeing it and go, oh, I see it, Mr. Wallace. If you can see it, great. But I still need to see a false statement before you tell me that your answer is no solution. Today, if the instructions don't tell you what to do, you may solve using any of our methods by graphing, by substitution, or this one is set up nicely for elimination, so I'm going to do that. Again, to help myself out, I'm going to put a coefficient of 1 in front of that x because there's one x, one y. This is 1x. Then I do plus a negative 1y here. And again, now it's set up nicely for elimination. I add it together. I get 2x. These guys cancel. So don't write down anything. 3 plus a negative 3 gives me 0. Don't stop here. It's very important. Solve the equation. Divide by 2. Divide by 2. X equals 0. This can happen. 0 can be your value for your x or for y. Once you've got that, now plug it on in. So I got 1x plus 1y equals 3. That's the first equation. I'm going to plug in 0 for x. Mr. Walls, clearly it's just 1y equals 3. Y equals 3. I could see that. Good. Write it on out as for practice, because today you're going to see that we could have one solution. We could have a point of intersection like here, 0, 3. Again, x can equal 0 or y can equal 0. That is possible. That is not a false statement. That's just a value or a solution for that variable. If you get a false statement, like 0 equals 8, that means no solution. Or negative 2 equals positive 2, that means no solution. But if x equals 0, make this note in your head, then continue on because your x value is 0. Plug it on into the other equation. We said we can solve using any of these skills over here. Today there will be one solution. There will be no solution, and there might be infinitely many solutions. These are your three choices. If it's one solution, like the last one, it'll come out to some point. 0, 3. If it's no solution, they are parallel lines. You get some sort of false statement. Here again, solve with whatever method you like. It's set up kind of nice for elimination with all the x's and y's on the same side. So I'm going to focus on either of them, since the x's, one's positive and one's negative, and the y, one's positive and one's negative. I'm just going to look here. I need to take and multiply that 2x times something to make it 12. So I'm going to do it by 6. Again, that gives me 12x plus a negative 24y. Distribute here in your notes, draw that loop, and don't forget it is not equals 10, it is equals 60. Now rewrite that other equation. Be very careful that you copy it correctly. Negative 12x plus 24, negative 12x plus 24y equals negative 60. Now it is set up nice, so we can add them together. The x's cancel, all right? That's what I was going for. The y's cancel, all right? So put down 0 equals 60 plus a negative 60 cancels. There are no variables. So then we must ask ourselves, is this true again? Does 0 equal 0? And since it's yes, then our final answer is infinitely many solutions. But like I said in the beginning, for me in my class, I want you to not just leave it at infinitely many solutions, because not every number works, but infinitely many solutions on the line. And now pick one. Pick either this first equation or the second one. I don't care, and write it down. Because if it's a solution to this line, it's a solution to the entire system. So it's not just any number, it has to be on this line here. So when you get a truth statement, don't just leave it at infinitely many solutions. Make sure you add in one of those equations from the original system. Again, this one's set up for elimination, so I'm going to do that. I'm going to take it times a negative 2, the first one. Let's get rid of those. So I got a negative 4x plus a negative 2y equals a negative 10. Draw the loops in your assignment. But you already did it in your head, Mr. Wells. I know, but I want to make sure you're drawing those loops in. So I should have been drawing those in as I was going through it. Copy the next one over. And we did that because now they're going to eliminate. So add them on up. We've got 4x and a negative 4x. Those guys cancel. 2y and a negative 2y cancel, so we're left with nothing on that side, which is fine. 0 equals, I'll add those together. We get negative 10. Is this true? No. Since there are no variables, we ask, is it true? No, so that means there is no solution. These are parallel lines. They are the same line. I saw that right away, Mr. Walls. Great. Show me the work. You must get it down to this truth, or in this case, false statement, before you can tell me no solution. Again, either using the words no solution or the shorthand for it. There's an example like this in your books. We're going to go an example just like this as well. The perimeter of rectangle A is 10. Perimeter of rectangle B is 5. Write and solve a system of equations. Since A is 10, I'll start with that. And then the perimeter all the way around. Don't just tell me that it's y plus 3x. In class, we'd have a great discussion that you haven't gone all the way around. You remember that this side is y, and that this side over here is also 3x. Rectangle B is 5 units. That's its perimeter. So don't just tell me it's half y plus 1.5 x. That's only 2 sides that you've gone across. Make sure you add up all 4 sides in this case. Go around the complete outside or perimeter of the shape. Clean up your equations, adding up like terms. So you get 10 equals 2y plus 6x. And again here, adding like terms with your x's and your y's. So we got 5 equals 1y plus 3x. I noticed something, Mr. Walls. Great. It said to write a system. So there's one step. You have a system of equations. But now it does say to solve them. So solve them using a method, one or the other. I'm going to start a new page because I've run out of room. You can continue to work your way down or off on the side of this. You can work into the next one. Again, you may pick any of them. I'm going to start with the bottom. I'm going to eliminate the y's. Pick the second equation because they're smaller numbers to multiply on up, so I felt like that would be less work for myself. Need to make it a negative, so that way this positive 2y will cancel with whatever I have here. It leaves me a negative 2y plus a negative 6. Copy that other equation over. I noticed something, Mr. Walls. Great. I don't see anything, Mr. Walls. That's fine as well. Copy it on over. Since I'm using elimination, I'm going to add them. These guys leave me with 0. Great. My y's cancel. 2y plus a negative 2y like I was going for. 6x plus a negative 6x also cancels. So with the word problem, I don't have anything to solve for. So we ask ourselves, is this true? And since it is true, since you say yes, there are infinitely many solutions to this equation, this system of equations. Since it says infinitely many solutions, please make sure you say, in my class, on the line, and then again, pick one of these, either the first or the second equation in the original system. I'm just going to go with that first one. And that there is our final answer. So this word problem doesn't actually give us a solution in a sense. There is no final answer of, well, x is 6 and y is 14, or find the perimeter. We can't go past that because we have infinitely many solutions. Again, today we looked at having no solutions and infinitely many solutions. In addition, you will still have one solution today as a possibility as well. You may use any of these methods to solve, but please remember, you need to have for no solution, you need to have a false statement. Otherwise, for infinitely many solutions, you're going to get 0 equals 0. But remember, if you get something that says x equals 0 or y equals 0, those guys are going to lead us down to some one solution. So you'll have a point. So be very careful that you pay extra close attention that if it's 0 equals negative 10, false statement, no solution. If it's true, 0 equals 0, you have infinitely many solutions. But if it is where x equals 0 or y equals 0, that's going to give us one solution where whichever letter or variable has 0, that value in your coordinate plane will be 0. Today we're still solving systems, but now we're going to see them. They're going to have one solution, like we've seen this entire time, and then some new things like no solution or infinitely many solutions. And then our goal is going to be able to also explain what no solution or infinitely many solutions means.